Hello, here is a summary of the carbonyl chemistry reactions we have learned under aldehydes and ketones. The reason I would want you to review this is because I'm going to require you to employ them in the next chapter of carboxylic acids and their derivatives. So what we learned is the use of a variety of nucleophiles to attack the electrophilic carbonyl carbon. For example, we can use water in the presence of sulfuric acid to form a hydrate. Or we could use an alcohol, like in this case ethanol, in the presence of sulfuric acid with the use of heat to remove water to form the acetal. Cyclic acetal can also be formed, and this is important in the protection and deprotection of the carbonyl of aldehydes and ketones. If you want to do protection, we simply need to use the right diol, like in this case a thin diol, the presence of sulfuric acid minus removal of water. If you want to do the deprotection, we just add water, the presence of the acid. The same strategy could be employed to generate cyclic thioacetals, which can help us to transform the carbonyl into an alkane if we do the deprotection using Raney nickel catalyst. We can also generate what is called an imine if we use primary amines. So in this case, the amine that we have is that, so in the presence of an acid. We could also use a secondary amine to form an enamine, of course in the presence of an acid. We can use the imine type of reaction to help us transform a carbonyl into an alkane if we employ Wolff-Kishner reduction. So this requires the use of hydrazine in the presence of an acid, followed by the use of base to reduce the hydrazone into an alkane. We can also do lithium aluminum hydride to reduce the carbonyl into an alcohol, or we can use sodium borohydride to do the reduction. Another strategy we could use is the cyanide. So if we use, for example, potassium cyanide as a source of cyanide, then we can do the nucleophilic attack, and then followed by a source of proton to help generate the alcohol group. So that forms what we call a cyanohydrine. We can also utilize the Wittich reaction. Wittich reaction involves the generation of what we called an ylide. Okay, so that requires the use of triphenylphosphine with an alkyl halide in the presence of a strong base like N-butyl lithium. So it just involves the insulation of a carbon where the oxygen was, and then of course that carbon could have alkyl groups or just the hydrogen atoms attached to it. We can also do oxidation if we use peroxy acids, like if we use peroxyacetic acid, then we can transform a ketone into an ester. Okay. We can also use Gilman reagent. So Gilman reagent transforms an acid halide into a ketone. How does it do that? Well, Gilman reagent simply requires the use of an alkyl halide. So in this case, we're just attaching one carbon. So we're going to have CH3, two of them attached to copper and lithium, so cupric lithium. So we need these two R groups, they need to be similar. So then we attach one of them on the other end. So what it does, just kind of cleaves that part and installs the alkyl group. We can also synthesize the aldehydes actually from esters. So we can, in other words, we can reduce esters and stop it at an aldehyde instead of letting go all the way to an alcohol. How do we do that? We use a bulky reagent like diisobutyl aluminum hydride, this one here. So we have aluminum attached to diisobutyl groups. Thank you for watching. Have a good one.